Hello everyone. Today we are going to deal with very basic questions about standard normal distributions. Now let's deal with tutorial number 5. Now our assumption is that X is normally distributed with these parameters. It means that 35 is the mean and 4 is the variance of this normal distribution. Now calculate the following probabilities. First one, probability of X less than 40. Pay attention, this is X, not Z. So that we should make it a Z-score so that we can read it from the standard normal distributions. In the exam, we don't give you all the tables about all the normal distributions that we know. It should be infinite number of tables. It's not possible. That's why we have standard normal distribution and we should read all the answers from that table. So whenever we ask you about X less than 40, we should at the end make it in such a format that Z is less than or equal something. Equality doesn't matter in normal distribution because we are dealing with a continuous density function. We talked about it before, right? So it doesn't matter. As long as you reach less than or equal a number, we can read it from the table. How to do that? If you remember, we have that formula. X minus mean of the normal distribution dividing by standard deviation, not the variance. So we should get the square root of this one, which is 2. So we do it to the left side of it and we make a z-score out of X. And on the right side, we should do the same for the numbers. So 40 that we have here minus the mean of the normal distribution dividing by square root of variance, which is the standard deviation. So when you reach this part, you can easily read it from the table. The same situation here with different number, you can test it. And when you reach 5, this is a big number, it means that it will cover all of the area under the normal distribution. Well, approximately all the area because it continues until infinity, as you know, but it's very close to 0, we could say, after 3.9. In the table I provided for you, it is 3.4, so above it you can consider almost equal to 1. So whenever you reach a big number over 3.4 in my case, or 3.9 in the tables in most of the books, so you can consider it as approximately equal to 1. Let's test it with another number, 35. You reach 0. Directly you can say this is half. You don't need to check the table because you know for standard normal distribution, the half of the area is less than 0. Because the mean of the standard normal distribution is equal to 0. All right, let's move on to the next one. Less than 30. In this case, 30 minus 35 makes it a negative number. In some cases, or I mean in some books or in different lectures, maybe you can read it directly from the table, but in our case, in our class, I just provide you the positive numbers. You see, starting from half to almost 1. So if you have the table, you can read it from the table for negative numbers very easily. But since we won't provide you this in the exam, that's why we should convert it. I already told you that this is possible by considering the other side of the distribution because it's a symmetric property of normal distribution. We told you about they are exactly equal areas. So to do that, whenever you see a negative value, you can make it positive and change the direction of inequality. And when you reach this part, again, we should consider the complement of that because we should read everything as the format of z less than a number. This is a cumulative CDF. That's why we should always consider z less than something. So 1 minus the probability of the same number, as you can see. Or directly, whenever you see this negative number here, just consider the positive one, but don't forget that we should subtract it from 1. So this is the fastest way that you can do. Directly, you can write this one instead of just considering this part of your normal distribution. In the class, we talked about it in details. So let's move on to the next one. Here we have an interval. In case of interval, guys, please pay attention to this one. This is very important. Let's see. For both sides of this inequality, we should apply the same thing we did for the previous questions. So we made z-score by subtracting from mean and dividing by standard deviation. We should do the same for both sides here. So at the end, we will have such a case. The next thing to do is to convert it into, again, less than or less than equal some values. In order to do that, please pay attention to this part. It's very important. First, we write the probability of this side. So probability of z less than 2.5. Subtract it from this part, but we should write the complement of that. So if z is more than 0, here we should write z is less than 0. And if we don't have equality here, we should have equality as well. But in case of normal distribution, we don't care about equality, as we say, because this is almost equal to 0. That's why you can write it like that. But if we ask you about binomial and Poisson distribution, they are discrete. That's why we should be careful about it. Okay, then the rest is just reading from the table and find the final answer. The same story here. The thing here about calculations that makes it harder is just because we have negative here. That's why we should be careful in our calculations. We already talked about the details in the previous question. So here, probability of x is equal to 37. Whenever we see equality, probability of a line under just inside an area, so this is almost 0. We can right away make it equal to 0, and you don't even need to make a z-score out of this. Here, probability of z less than 1.01. You see, we already calculated the z-score, and we know that we are asking you about just this probability. Whenever this is x, we should make a z-score. We should have some extra calculations here. Whenever we ask you directly about z less than something or z in an interval or something, you can read it from the table without calculation like this. So this one is easy for you. You can read it from the table. This one has negative value, and you know we should write the complement. And in the table, you have only 2 decimal points. So whenever you face such numbers, you can approximate it. Forget about 2. What's the closest number to it? This is this one. If it was 7, then 1.02. So we round it up, right? The number to that, so that is the best approximation we can do. Because inside this table, you can see we have just 2 decimal points. First decimal point is here. Second one is here. Here, for example, 0.11, 0.53. So we can read it like 0.53 from this side of the table. We already talked about it in details in the class. Again, another equality. So I expect you guys already know this is equal to 0. And we can ask you again in an interval. Let's practice it one more time. So let's see how I can change this one to the format of less than or equal something. So in that case, consider this one. Probability of 1.24 minus complement of this one. You see, we change the direction of inequality, and we write the same number. If this one has doesn't have equality, so here we should have equality. But since it's a normal distribution, this is a continuous distribution. That's why it doesn't really matter. We know that the equality probabilities are almost equal to 0. Okay, so here you can see we just calculated it, and this is the final answer. Well, as you know, because of this coronavirus thing, suddenly we had to switch to online education. I had to rush to make several videos for different courses. In case if you observe any miscalculations, please let me know. My old students from other universities asked me to share such videos, so I'm going to upload it for them as well. I'm going to put it on YouTube so that everyone can benefit from it, since we are dealing with these difficult times around the world, so that we can consider it as a donation for those universities which they couldn't convert to online education very fast. I'm Dr. Mani Mehraei, and if you have any questions, you can also leave your comments here. See you guys.